Let's talk about ratios and rates. So a ratio is a comparison of quantities measured in the same units. A ratio can be written in the form 3 to 6 or like a fraction. Fractions, ratios can also be reduced. So we're given a ratio here, 20 to 24. How can we simplify or reduce? Well, I can divide both by 4, so I would actually have an equivalent ratio of 5 to 6. 21 to 15, how do I reduce that? Well, both can be divided by a factor of 3, so then 21 to 15 can be reduced to 7 to 5. Now we have 3, 10 to 25 to 45. All three of these can be divided by a factor of 5. So when I do that, 10 divided by 5 gives me 2, 25 divided by 5 gives me 5, 45 divided by 5 gives me 9. So the reduced ratio is 2 to 5 to 9. Bit of a word problem here. A 350 milliliter can of concentrated frozen orange juice is mixed with a 1050 milliliter jug of water. A. Write a ratio in simplest form to compare the amount of OJ concentrate to water. So the initial thing we're looking for is OJ to water. That's the ratio we want. So I know that I have 350 mils of frozen OJ, and I know that I have 1050 of water. So the ratio would be 350 to 1050. Now we're going to go ahead and reduce that. Both 350 and 1050 can be divided by 10, so I end up getting 35 to 105. Both can be divided by 5, so I can keep reducing, 7 to 21, and both 7 and 21 can be divided by 7, which can end up with a lowest ratio of 1 to 3. This should look very similar to what we talked about with fractions and reducing fractions. We just keep reducing it until we can no longer reduce the ratio. Write a ratio in simplest form to compare the amount of concentrate to total juice. Okay, so we have orange juice to water is 1 to 3. Now when we add them together, you have 1 part orange juice, 3 parts water, you actually have a total of 4. So the juice contains 4 parts, right? It has 1 thing of orange juice, 3 things of water, which gives us a total of 4. So the ratio compared amount of OJ concentrate to total juice, in this case would be the OJ would be 1, the juice in its entirety as the whole would be 4. How much frozen concentrate is needed to make 1,200 milliliters, or 1.2 liters, of juice? Okay, so I know my ratio of concentrate to juice is 1 to 4, and I need to make 4 into 1,200 milliliters. And how do I do that? Well, I multiply it by 300. So 4 times 300 gives me 1,200. What I do to one side to make it the same or to make it equal, I have to do it to the other. So 1 times 300. I end up getting 300 to 1,200. So what that means is that 300 milliliters of frozen concentrate is needed for 1.2 liters of juice. Third example, we're going to be dealing with 3 different ratios. If you had 300 Valentine's jelly beans, red, white, and pink, and the ratio of the red to white to pink was 5 to 2 to 3, how many of each color is there? Okay, so I have the ratio red to white to pink, which would give us the total. I have 5 red, I have 2 white, and I have 3 pink. 5 and 2 and 3 gives us a total of 10. So I need to have 300 total. So how does 10 become 300? Well, I multiply it by 30. And what I do to the total side to get my total value, I have to do to every single ratio. So 5 times 30, 2 times 30, and 3 times 30. So I'd end up getting 150 red, 60 white, and 90 pink Valentine's jelly beans in the 300 total that I would have. A rate compares quantities that are measured in different units, right? So ratio is same units, this is now different units. A unit rate describes how many units of the first type of quantity correspond to 1 unit of the second type of quantity. Basically, that's a lot of words for saying like kilometers per 1 hour, or cost per the 1 item, or earnings per the 1 week. That's where this 1 comes in. So we're going to calculate the unit rate, so per 1 something. In this case, it is a car traveled 360 kilometers in 4.5 hours. So 360 kilometers divided by 4.5 hours. Well, we know from fractions, I need to change that to a mixed number. So I go ahead and I change that to would be 9 over 2, and I'm going to multiply it, but I got to flip it, right? 2 over 9. So now I have 360 over 1 times 2 over 9. I can reduce here. I can divide 360 by 9 and 9 by 9. So when I divide 9 by 9, I get 1. When I divide 360 by 9, I get 40. Now I multiply across the top. 40 times 2, and then 1 times 1. So in this case, that should be 80. 40 times 2 is 80. 80. There we go. My bad. Next example. Ryan typed 500 words in 12 minutes. Okay, so 500 into 12. So we can write that as a fraction, 500 over 12. We can keep reducing it, 250 over 6, 125 over 3. And I'm looking for 1 minute, so I need to divide it by 3, which gives me approximately 41.2 words per that singular minute. Let's say you have a job, you make $170 in 20 hours. $170 over 20 hours is the same as saying 17 over 2, which was about $8.50 per hour. When we try to divide this by 2, we need to divide 17 by 2, we get about 8.5 or 8.5. Okay, this table shows the price per case of water at different stores. Evelyn is buying 120 bottles of water. At which store should Evelyn buy her water to pay the least? How much would it cost? Okay, so we have four different stores: Cheapies, Food Mart, Variety Foods, and Super Grocers. We have our their price per case, $1.75, and how much you get in each case. So we're trying to find a unit rate, or comparing them to a single bottle. So for Cheapies, I go $1.75 for 8 bottles, gives me about 22 cents per bottle. For Food Smart, $2.25 divided by, I get 12 in the pack, which means that I have 0.19 or 19 cents per bottle. Variety Foods, $4.59 divided by 20 gives me 23 cents per bottle. Super Grocers, $4.99 divided by 24 gives me 21 cents per bottle. So now it's really easy to look at, okay, which one was cheaper? Well, which one costs the least amount per one bottle? That would be Food Smart right here. It only costs 19 cents per that bottle. Last example. David and Shawnice take a trip that is 450 kilometers long, or a 450 kilometer trip. David drives a car and uses 7 liters of gas per 100 kilometers. Shawnice drives a truck and uses 12 liters of gas per 100 kilometers. If gas costs $1.23 per liter, how much more will it cost Shawnice than David to drive 450 kilometers? And we need to show our work. So for David, we have a rate of 7 over 100, so 7 liters per 100 kilometers. Well, we're going 450, right? So how do I get 100 to turn into 450? I times it by 4.5, and I same at the top here. So 7 multiplied by 4.5, I get 31.5. Okay, so that's how many liters it's going to take David to drive. At the rate of at the rate for gas, which is $1.23 per liter, I take the amount of liters needed, 31.5, multiply it by how much it costs per 1 liter, and then I have the amount it's going to cost David to drive 450 kilometers, which in this case, $38.75 in gas. Shawnice drives a truck, so she's 12 liters per 100 kilometers. Again, I need to turn this into 450, so I multiply 100 by 4.5. I do to the top as well. So this means that Shawnice uses 54 liters in order to go 450 kilometers. So 54 liters times the rate per liter, which is $1.23, it would be 66.42. So it's going to cost her $66.42 in gas in order to travel that far, right? So then as we scroll down here, how much more? So we're looking for the difference between 66.42 minus 38.75. The difference is going to be $27.67. So therefore, it costs Shawnice $27.60 more to travel 450 kilometers.